I'm going to do 3 of these with you simply because sometimes the algebra is a little hard to remember. So this is number 1 on the sheet that I've given you, and it says cosine of 105 degrees. And when you look at your unit circle, 105 degrees is not on there, so we don't know the exact answer for that. So in order to find an exact answer, you need to find 2 things that you can add or subtract together to get 105. And I'm going to use, let's see, I think I'll use 60 degrees and 45 degrees. So you need to use 2 things that are on your unit circle. And my formula for sum and difference for cosine is cosine of a plus b, and this is a and this is b, simply because that's the order that I wrote them in, is cosine of a, so cosine of 60 times cosine of b minus sine a sine of b. So you need to know those things to be able to put them in the formula. So sine of 60 is square root of 3 over 2, and sine of 45 is square root of 2 over 2. Remember, these are all on your unit circle. Cosine of 60 is 1/2, and cosine of 45 is square root of 2 over 2. So when you're matching these up, A is 60 and B is 45. So here, 60, 45, 60, 45. And they're sitting side by side, so you're multiplying them. So the cosine of A, the beginning, the cosine of 60 is 1/2 times the cosine of B, so the cosine of 44 is square root of 2 over 2, minus, that's the formula, the sine of A, so the sine of 60, times sine of B, so the sine of 45. And you just need to multiply, and remember that when you multiply, you don't need a common denominator. You multiply straight across, and you cancel if you can, so 1 times the square root of 2 will be square root of 2 over 4 minus square root of 6. You can multiply things that are inside the same kind of radical. So my answer here would be square root of 2 minus square root of 6 over 4. So there's that one. So let's clear this and look at another one. Let's look at number 13, tangent of 75 degrees. And again, you want to look at your unit circle and find 2 things. So I'm going to use 30 and 45. And you can use anything on that unit circle. Here's your formula. Tangent of A plus B. So A is 30 and B is 45. Is tangent of A, so tangent of 30. Plus tangent of B, so tangent of 45, over 1 minus tangent of A, so tangent of 30, times tangent of B, so tangent of 45. Now remember that tangent is sine divided by cosine. So tangent of 30 is sine of 30 divided by cosine of 30. And sine of 30 is 1/2. I'm going to go over here to the side. So sine of 30 divided by cosine of 30. And cosine of 30 is square root of 3 over 2. And remember, when you divide, you flip the 1 on the right. So our tangent would end up being 1 over the square root of 3, and that's for 30 degrees. Now, we don't need to rationalize until we're finished, but remember, you don't let a square root be on the bottom. So tangent of 30 is 1 over the square root of 3 plus tangent of 45, since sine of 45 and cosine of 45 are the same thing. When you divide 2 of the same thing, you get 1. So that would be a 1. So 1 minus, again, tangent of 30, which we know we just did, times tangent of 45, which we just did. So we get 1 over the square root of 3 plus 1 over 1 minus 1 over the square root of 3. Now, this is a complex fraction. And what you can do to rationalize these is you can find the common denominator of the whole fraction. What makes it complex is that it has fractions within a fraction. And if you find the common denominator of the whole thing, every single denominator, and I have denominators of square root of 3 and 1 on the top and 1 and square root of 3 on the bottom. So the common denominator would be square root of 3. And if I take that and I multiply square root of 3 times everything on the top and everything on the bottom, that's the same as multiplying by 1, because square root of 3 over square root of 3 is 1. And that would rationalize everything. So if I multiply this by square root of 3, and this by square root of 3, and this by square root of 3, and this by square root of 3, it will get rid of the square root of 3's that are in the denominators, because this is over 1, and so I can cancel. So 1 plus the square root of 3 over square root of 3 minus 1. Now that got rid of all my square root of 3's in the denominators of each fraction, but I still have a square root of 3 in the denominator of the bottom. And you can't have something like that, so you need to rationalize. So I'm going to clear this slide and put what my answer is so far on there. Let's see. So this is what I have so far. And to rationalize, remember we did this before with sine and cosine. And what we do is we take the conjugate of the bottom, and the conjugate of square root of 3 minus 1 is square root of 3 plus 1, and we multiply it times both the top and the bottom, and we'll have to FOIL. So on the top, when I FOIL, 1 times square root of 3 is square root of 3. 1 times 1 is 1. Square root of 3 times square root of 3. Whenever I multiply square root of 3 times itself, the number comes out of the radical. And then the square root of 3 times 1 is square root of 3. Now, those square roots of 3's are just like x's. So this is like 1x and 1x, and if I were to add 1x and 1x, I would get 2x. So with this one, I get 2 square root of 3, and the 1 plus 3 is 4. So on the bottom, I get square root of 3 times square root of 3, which is 3. Square root of 3 times 1 is plus square root of 3. Minus 1 times square root of 3 is minus square root of 3. And minus 1 times 1 is minus 1. So these two cancel because they're opposite signs of the same number. And then 3 minus 1 is 2. And any time you have numbers in front of radicals or variables and they all three, they form like a triangle with that sign because the 2's underneath both of the terms on the top, you can cancel those three numbers with the common term. And 2 will go into all three of those numbers. So 2 goes into itself once, and 2. So that's why your sheet that you have that I gave you has this as its final answer. That's how they're getting that. And I know that's complicated. That's why I'm doing these examples for you. So we're going to do one more example, and then you need to do some of these on your own and make sure you can get them. But this is number 24. And in number 24, I'm trying to find the tangent of 13 pi over 12. Now, some of you have a really hard time with these that are in radians. So one of the things that you might want to do is just change that to degrees by multiplying by 180 over pi. And if you do that, the pi's cancel, and when you do your math, you're left with 195 degrees. Now you can change this back as you do this because that's the kind of answers that you're going to want. If the problem's in radians, you're going to want those in radians. But in order to find the two numbers that you want to use, you might want to change them to degrees, because when I see that it's 195 degrees, I can choose to use for my unit circle 135 plus 60, and 135 is 3 pi over 4, and 60 is pi over 3. So I know now that 13 pi over 12 is the same thing as 3 pi over 4 plus pi over 3. So those two things work. So I'm going to clear this slide and put your numbers up there. So tangent of 13 pi over 12 is the same thing as tangent of 3 pi over 4 plus pi over 3. And my formula for tangent is tangent of A, so tangent of 3 pi over 4 plus tangent of B, so tangent of pi over 3 over 1 minus tangent of 3 pi over 4 plus tangent, times, let's just plug a parenthesis in there, times tangent of pi over 3. So you need to pull those things from your unit circle. So we've got everything plugged in there. We just need to figure out what tangent of 3 pi over 4 is. And tangent is sine over cosine. Sine of 3 pi over 4 is square root of 2 over 2. And cosine of 3 pi over 4 is negative square root of 2 over 2. So the tangent of 3 pi over 4 is just negative 1. So that one's going to be easy to take care of. So this one is negative 1. And that one is negative 1. Tangent of pi over 3 is sine of pi over 3 over cosine of pi over 3. And sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2. When we divide those, we get square root of 3. So tangent of pi over 3 is square root of 3. So we now have minus 1 for this one, plus square root of 3 over 1 minus 1 times square root of 3. So we have on the top minus 1 plus square root of 3. And on the bottom, we have a negative times a positive is a negative, but we're subtracting, so we have 1 plus square root of 3. And again, we can't leave that negative down there, so we're going to rationalize. So the bottom's conjugate is 1 minus square root of 3. So when we multiply, let's just clear that out. And then put this on a page for us. So times 1 minus square root of 3 over 1 minus square root of 3. When I FOIL out the top by taking this one times both of these and this one times both of those, I get negative 1 plus square root of 3 plus square root of 3 minus 3. On the bottom, when I FOIL that, I get 1 minus 3. So I end up with minus 4 plus 2 square root of 3 over negative 2. I can take that negative 2 and divide it into negative 4 and the plus 2 because it'll go into both of them. So negative 2 into negative 4 is positive 2. And negative 2 into 2 square root of 3 is minus square root of 3. So that's how you're getting your answers from your sheet. So that's what these look like. I would suggest that you do several of these on the sheet that I gave you. I gave you the answers, so you need to make sure that you can get those. And contact me with questions.